Welcome to a new video series on real analysis. This is going to be a full course walkthrough with exercises, and it also serves as a companion to the textbook by Zorich. What that basically means is that we are going to follow the textbook Mathematical Analysis 1, second edition by Zorich. This is going to be a course walkthrough, which basically means that it's kind of showing as if I were taking the course, right? Basically showing you my understanding of what I read in the textbook and then solving selected exercises. This is, right, like the very first part of the textbook is about preliminaries, and it's necessary and important. But I'm going to skip it because I am currently, simultaneous with this video series, also making a video series on discrete mathematics. Now, that video series on discrete mathematics contains all you need about logic and then some. And so, because it's always hard to sort of thread the needle about like just exactly what is the right amount to talk about when it comes to logic and set theory for what you need in a course in analysis. What I kind of figure is, well, you can read the textbook and get whatever you can get from that. And if you need more, you can go to the discrete mathematics series. If there's anything among all of those resources that I don't cover and you'd still like to see covered, you could always leave a comment on one of the videos. And if I have the time, then I might be able to fill in that gap. But also, I don't want to make a bunch of redundant videos, right? So if I'm going to talk about it somewhere, I'd rather just talk about it in one place in the discrete math video series. And then anytime that kind of material is necessary, I just refer everybody to that. So for all of those reasons, I am skipping the section at the beginning of this textbook on logic and set theory. But otherwise, I do intend to cover everything in the textbook from chapters 1 to 8. In fact, I kind of suspect that because I'm kind of interested in some of the stuff that is in this textbook and the sequel to the first book, there's a good chance that once I'm finished with this series, I will continue on to the second volume. A prerequisite to real analysis is calculus, and many American universities make that a formal prerequisite for analysis. It is really not a strict prerequisite. You will find that you use essentially none of your calculus skills in a real analysis course. The only reason why it's made as a prerequisite sometimes is because knowing calculus helps you to understand why we're doing some of the things that we're doing. It helps you to get a somewhat more physical and intuitive understanding of the objects that we study. But like I said, it is not strictly necessary. I do recommend it. I mean, honestly, you're going to learn all this stuff eventually. So I don't see why you wouldn't go and learn calculus before learning this material, because I do think that calculus is easier to learn. And once you learn it, it helps you to learn this material. So I would recommend it, but it is not a strict prerequisite. Okay, so I recommend it. It can be helpful if you have any experience or background in proofs. This could come from a discrete mathematics course or a course purely focused on logic and proofs, but in any case, that's helpful, but again, not a strict prerequisite. If you did feel like you needed to, backtrack a certain amount and go study proofs or something like that, you may not need to go all the way through a discrete math course, right? I have this video series that I'm producing right now on discrete mathematics, and you don't need all that is found in a discrete math course. A big portion of it is not useful for real analysis. So all you really need from a course like that in order to study this, if you're trying to just get to this material rather than, complete an education in mathematics generally, if you were doing that, then maybe you just want to learn everything and then just learn the whole discrete math class. But if you're trying to just get straight to this particular topic, then you don't need all that you find in discrete math. You really just need the portion on logic and set theory. And I'll say a final sort of word about the structure of these videos. You learn the most when you are doing exercises, right? And therefore, I am going to try to structure these videos around the exercises at least as much as around the content, right, the exposition. I will show solutions to exercises, but this is dangerous because, you may be tempted to simply watch me solve problems. And if you are trying to learn math merely by watching, then you will absolutely fool yourself about how much you're really understanding what you're seeing here. So, what I strongly recommend any viewer to do is play these videos. I will end each video. I'll try to anyway. May not be perfect at sticking to this pattern, but I will at least aim for the pattern of ending every video on the statement of a problem. You should not let the next video play. You should stop the video after or the playlist once the video has ended, and work on the problem on your own. Make a very good, serious attempt before letting the next video play. At the very beginning of the next video, I will show my solution to that exercise. Okay, now, I will say that most of us would naturally err, if we were going to make a mistake about how much time to spend on a given exercise. I think, without really mustering some will, most people would spend too little time and give up too quickly. I think that's fairly natural. But it is possible to err in the other direction. It is possible to spend too long making an effort at a problem that you can't figure out. And at some point, you really should check your answer or just watch somebody else give a solution. And finding that balancing point can be a tricky thing, right? You don't want to be counterproductive. And this is one way to be counterproductive, spending longer struggling on something. And sometimes you just learn really well by giving a really good hard effort and then giving up and going and watching some solution. So it's tricky. I cannot give you any advice as to how long you should spend on a problem. That is just very dependent on the kind of problem and possibly other factors. So I won't try to give any advice, but this is the kind of skill that you just acquire by doing it a whole bunch. So just, spend as long as you can, trying as hard as you can, until you come up with some kind of an answer before you give up, or maybe you think you get the answer, and then you just check your answer against mine. But in any case, okay. So like I say, I am going to try to end every video on an exercise, and at the start of the next video, solve that exercise. Okay, in the next video, we'll start doing some real analysis.